Hi there, and thank you for taking the time to listen to this talk about how machine learning can be used to improve transaction monitoring. As Marcus Player mentioned in his opening speech, new technologies have great potential. And our aim of this talk is to teach you a little more about AI and machine learning and talk about one concrete example of how machine learning can be used to improve transaction monitoring efficiency. Next slide, please. My name is Talat Bergheim. I am a data science manager at BearingPoint, and I work in our data and analytics team across industries, but my main focus is within the financial sector. Together with me, I have Matthias Möller, which is a data scientist, also in our data analytics practice in Oslo, in Norway. Next slide, please. Our topic for today is to give you a high-level view of some trends in AI and machine learning before we explain some topics within advanced analytics that can be utilized for AML and CFT. And after that, we will explain about a project that we did and the results of that project. Next slide, please. In their 2021 artificial intelligence heat map for banking and investment services, Gartner interviewed CIOs and other banking executives regarding their views on AI and machine learning. And the last couple of years, this has been increasing. And today, the customer-facing side of banks is where AI and machine learning have come the farthest. But the last couple of years, these executives have seen that risk management and compliance has really increased and are getting higher up on their agenda as a driver of the use of AI in banks. And what they see is that by using AI and machine learning, you can have a neutral tool, and by that you can avoid the human bias that you traditionally have been getting by using manpower, as well as you can reduce the need for using manpower on repetitive jobs. Next slide, please. The IDC, the International Data Corporation, projects that from 2020 to 2024, the spending on AI development and technologies will increase by 100%, or in other words, double. Wall Street Journal has written an article referencing a McKinsey report projecting that by 2030, on a global scale, the global GDP will have increased by 16% by the adoption of AI. And in a report by Microsoft and EY, where they interviewed a lot of executives across European banks, 71% of these companies responds that AI is considered an important topic on the executive management level. And what these trends underline is that the coming years, AI and advanced analytics will move on from where it might be today in a piloting stage, and it will actually be shifting to actually operationalizing AI. These are some high-level trends that underlines that this is really happening now. So I think it's useful to learn more about this. So Matthias, please say something about both transaction monitoring and how these technologies can be utilized. Next slide, please.
Right. Thank you, Talat. I think the numbers you show there pretty convincingly tell us that there definitely is a large room for artificial intelligence within the area of anti-money laundering. Today, we'll be discussing the use of machine learning in transaction monitoring. There's, of course, many other areas within anti-money laundering where you could use artificial intelligence. But what we've typically seen is that transaction monitoring is a natural place to start. So in this section, we'll first describe some of the challenges that we see in the transaction monitoring systems that are typically implemented today. We'll then give kind of an overall view of the different machine learning and advanced analytics techniques that we can use to solve some of these challenges. And then we'll go through an example of how we've helped one of our clients to improve their transaction monitoring system by using a supervised learning algorithm. Right, so before we start with the transaction monitoring challenges, I thought it would be worthwhile to just very briefly describe how a typical transaction monitoring system works. I'm sure most of you are familiar with this already, but what you typically have is some type of software where all your transactions of all your customers are passed through. And typically you have manual rules that are developed to flag the transactions that you suspect that are suspicious. And the transactions that are actually found to be suspicious, they are flagged, and then they go through some manual review. And then ultimately, if the manual reviewer or multiple levels of this manual review, if they find that this transaction or this customer is suspicious, the customer will be reported to the authorities. And with this system, there's several challenges that we've highlighted here that we typically see. The first one is that this type of system with the manual rules, or the manually implemented rules, they generate a high number of false positives, meaning that a lot of the transactions or the customers that are typically flagged, they're not actually reported to the authorities. So the manual reviewer actually closes the alert and says, here, there's nothing suspicious going on. So this is a very big challenge that we've seen for many different banks and financial institutions. The second is, Talat mentioned it previously, that there's just an overwhelming number of alerts in total, meaning that you need you need to employ a lot of these manual reviewers to actually go through the alerts. So there's a lot of manpower involved there, and since there's also a high number of false positives, there's a certain amount of repetitiveness to this whole task of going through alerts that you're already suspecting that are not going to be suspicious. The third challenge that we want to highlight is that these rules are often quite time-consuming to maintain. What I mean by that is what you typically do is above the line and below the line testing of the thresholds that you have in these rules. And when you're sitting and doing this, for example, with analysts in your team, this can be quite time-consuming and difficult. The fourth challenge that we wanted to highlight is the difficulty in detecting new suspicious patterns. So what the criminals will typically do, or the money launderers, they'll change their behavior to stay one step ahead of the curve. But with traditional methods, you're typically all bound to what you know already and what the criminals have already done. And it's hard to find where are these outliers, where the customers differ and they're doing something different or something new. And the fifth challenge that we wanted to point out is that the individual rules are often quite broad and cover wide risk spectrums. And this, of course, links back to the second challenge of the overwhelming number of alerts in total. So if the rules are quite broad, it leads to two things. One, it leads to a lot of alerts, which can and a lot of times be false positives. But it also makes it challenging for the manual reviewer to actually know what to look at. Because if it's a very broad rule, then you could say that there's a lot of transactions or possibly a lot of different things to look for if you want to check whether this customer is suspicious or not. Next slide, please. So there are several different techniques, both machine learning techniques and advanced analytics techniques that can be used to solve some of these challenges. The first method on the left here, you could say, is the traditional method, and in a lot of ways, the cause of a lot of these challenges, and that's using traditional rule-based methods. I've already mentioned the challenges here, that they typically produce a high number of false positives, but they are typically a natural place to start when you implement a transaction monitoring system. And in a lot of ways, we've seen that they're often preferred due to their ease of implementation. The first machine learning technique that I wanted to touch on today, and that we'll also go through in the project example in a few minutes, is supervised learning. So supervised machine learning is a method of machine learning where you train an algorithm based on what you know from your history, and in this case, from your previously reported customers. So supervised learning, in the supervised learning model, you train an algorithm to find the patterns that are common for the customers that have previously been reported. And what the supervised learning model will do is find these patterns a lot more effectively and a lot more efficiently that you could do manually. And therefore, it can aid in reducing the amount of false positives and increase the overall transaction monitoring efficiency. A second type of machine learning algorithm that I thought it would be worthwhile to mention is unsupervised learning. And contrary to supervised learning, unsupervised learning does not rely on the fact that you have previously reported customers. So it doesn't train based on those previously reported customers. And due to this fact, unsupervised learning can be quite efficient in detecting new and previously unseen patterns of suspicious behavior. So unsupervised learning can, for example, detect anomalies in your customers, or where certain types of customers are standing out and you want to review those. And this can aid in increasing the overall transaction monitoring effectiveness. The final technique that we see that some banks are implementing is network analysis. And network analysis is not really, I wouldn't say that it's a machine learning technique, it's more of an advanced analytics technique. Network analysis is really a different way of modeling your data, where you don't look just at one customer, but you look at a network of customers or a network of transactions and products. And with this technique, you can, for example, detect customers with this complex money flow, or you can find communities where there's suspicious patterns of transactions. Right, so before we go into the project example, I wanted to discuss another aspect of machine learning that's quite relevant in anti-money laundering. So next slide, please. And that's the white box versus black box problem. And you can generally say that there's white box machine learning algorithms and there's black box machine learning algorithms. And I'll explain what the difference is through an example here. So we have Tony Soprano, who is a known criminal. He's actually a mafia boss, and he's transferred $100,000 to tax havens. A black box machine learning model will just tell you, right, so Tony Soprano and his information and his transactions will go through the model, and the model will tell you Tony Soprano is suspicious. And that's quite problematic because the model doesn't tell you what is suspicious about Tony Soprano. And in the case where you have a manual reviewer that's going to look through this alert and actually do a double check or a triple check and see, right, is this customer actually suspicious and should we report him to the authorities? A black box model makes that very difficult because there's no place to start looking. You have to look through a lot of transactions and a lot of information in order to verify whether this is a true positive or a false positive. Whereas with a white box algorithm, the algorithm not only tells you whether the customer is suspicious or not, or the transaction is suspicious or not, it also tells you why. And in this way, the manual reviewers have a natural place to start and they know where to start looking. And this makes the whole process of manually going through this alert a lot more efficient. And that's why we generally tend to recommend implementing white box machine learning algorithms in transaction monitoring systems.
Just one comment from me here as well is that another strength of white box machine learning algorithms is the privacy part, and with regards to GDPR, that it is a strength that you can explain what actually happens with the customer's data with regards to our rights as customers, which is of course a lot easier with the white box.
That's a very good point, Talak. Very good point. Right. So next slide, please. So now we'll go through the kind of the method of developing such a supervised machine learning algorithm and a white box supervised machine learning algorithm. So in a broad sense, you could say that you first have to create a data set, you then have to train your model, and you then have to implement it. But you see all the way on the left here, we start with the risk analysis. And why do we do that? The reason is that you need some way to create the variables that you're going to use in your data set. And typically in a risk analysis, you have certain indicators that you point to. For example, you can take the example from the previous slide with Tony Soprano, who's transferred money to tax havens. Typically, if a bank or a financial institution sees that as a risk, that will be pointed to in the risk analysis, saying, right, we see customers or transactions to financial havens as entailing a higher risk for anti-money laundering. And what we would typically do then is, or what is natural then, is to create a variable in your data set, somehow describing this risk factor, which is indicated in the data in the risk analysis. So then you would, for example, create a variable with the sum of transactions to financial havens in a certain period. And we do this for different customer data sources. Such as the customer itself and its information about the customer's products, the customer's transactions, the customer's public tax and KYC data, and finally, since this is a supervised machine learning algorithm, we use the historical SARs, and that's the historical suspicious activity reports. And this will be a yes/no column saying whether the customer has previously been reported or not. And the machine learning model will ultimately train based on this column to find the patterns of those previously reported customers. And in the final phase here, you see that there's a rule set generated. And that's because that's due to what I mentioned on the previous slide of a white box algorithm. So we've done this typically using a machine learning algorithm that we've developed ourselves called Hypercube, which translates the results of a machine learning algorithm into a rule set that you can develop in your typical transaction monitoring system. So next slide, please. Now, the way this model works is that it's illustrated quite simplified here on this graph. So you have the purple dots here, which are customers that have previously been reported to the authorities, and you have blue dots, which are customers which have not been reported to the authorities. So the algorithm searches through all the dimensions or the variables that you've provided in your data set, looking for these clusters where there's a higher density of previously reported customers. And here you see that this is quite a simplified example with only 2 variables, but here you see that the customer, if it has between 80 and 100,000 Norwegian kroner of transfers to tax havens in the past year, and cash withdrawals in the past year between 50 and 100,000 kroner. And again, this is just a simplified example and not a real world case. But in this example, that is a cluster with a higher density of previously reported customers, and the model then translates that back into a rule which can be implemented in your typical transaction monitoring system. And what we've typically seen is that not only due to the nature of transferring into these rules does it make it a white box algorithm, which is easily understood by the reviewers, it also means that they're very understandable, and that you can kind of get a prioritized list of these rules that you can implement in your system, which is very effective. And it can also, what we've seen is replace the old transaction monitoring rules. So the rules, you don't lose a lot of the previously reported customers, and therefore you can turn off the inefficient rules that you've had previously and replace them with a more efficient, improved rules that you generate here. All right, so now Talak is going to go through some of the results that we've seen when implementing this supervised learning algorithm.
Yeah, thank you, Matthias. And just to stay on this slide for one more minute, I would like to underline this point that in the data set that we used here in our project, we created the data set of about 600 different variables. So for each customer, we look at 600 different data points at a time and try to find patterns across these customers and across the customers that were reported or not. So this is why the amounts of data are simply too large to be looked through by an individual. So this is why AI and machine learning is a great tool for this task.
That's a very good point, Tarlak. And I think you can also mention there that I guess in a lot of situations, you typically have some variables that you suspect are the main drivers of these customers being reported, whereas the model might tell you that actually it's some other variables that you weren't previously aware of, which are actually the ones that are driving these customers to being reported.
Yeah. Thank you. So after we did what Matthias explained, we tested and evaluated these rules in production at real and updated customer data. Next slide, please. So in this project, we had 2 work streams, and we actually then created 2 different models, one within the retail customers and one for the corporate customers. And by utilizing these new machine learning generated rules for the retail customers, we increased the number of true positives compared to the traditional rule set by 5 times. And of the customers that were highlighted by our new rules, the investigators of the bank considered 50% of them to be relevant to investigate. And that is a huge increase compared to the previous rule set they have had. For the corporate customers, the differences between the customers are a lot more varied. You have, in this segment, you have from the one-man single employee corporate institution to the institutions that employ several thousand people and have billions of kroners worth of transactions. So this is a more difficult task. But even in this segment, we were able to increase the number of true positives by 3.5 times. And 32% of the alarms generated were considered relevant. And again, these are great results. And what these results do is that they allow the investigators of the bank to spend less time investigating false positives and focus more time on investigating the suspicious cases. Next slide, please. So, so this is a quick overview of our methodology and experiences in this domain, especially within supervised learning. And what we would recommend is that banks go from their traditional rule-based methods and that they investigate and learn from these new methods for using machine learning in this domain. And we recommend to start with supervised learning because there it is easier to evaluate your models and understand what actually happens. And then when you have gotten some experience there, we recommend investigating these other techniques as well.
If I can jump in there, Tarlak, I think another point to mention is that When you start with supervised learning, it typically aids you in reducing the amount of false positives and therefore also the total number of alerts overall. And once you've kind of gotten the number of false positives under control, then you have more room to move on to unsupervised learning, where you typically would find new patterns of suspicious behavior. So there's also a natural flow here in terms of what's most effective for the banks.
Yeah, thank you, Mattia. That's a great point to make as well. So next slide, please. This was our talk and our experiences in this domain. We covered a lot now, so if you have any questions, please do not hesitate to reach out to either the organizers or Matthias and I for further questions and answers or presentations. We have 2 more minutes, so if there are any questions, then we could take them, but the next session, starting in 2 minutes, will be the session 3, the keynote and discussion about the EU Action Plan on AML and CFT.